Robert, welcome back. Thanks for
having me. Thanks for having me here.
Thanks for coming back on part 2 to finish out this episode. How you been?
Doing well. Can't complain. Nobody's listening anyway, so it's all right. No, doing well. Blessed. There's no doubt about it.
Good deal. Wanted to get back into our conversation about UPSs and kind of just start off with efficiency of UPSs. I know typically we see double conversion UPSs now. And then a lot also offer an eco mode. And
yes.
So how is efficiency impacted between normal double conversion and say eco mode?
Yeah, so I like to kind of get a little background to that. So historically, older UPSs and still what we still manufacture for rack mount small equipment, IDF closets, things like that, or if you bought something to take home, right? If you went to Best Buy and bought a UPS, for your home computer, it'll typically be a line interactive UPS, right? Which is ultimately our power source utility generator has a direct line to the load, and then we have kind of a sidecar of our backup equipment that's actually going to back that up. Our inverter and our battery will actually back that load up. So we consider those acceptable for smaller loads, less expensive loads, things like that. Ultimately, I usually say that the type of UPS you apply has a lot to do with the cost of what the end device is, right? And how it should be protected. So why we don't see those on a lot of big systems is, we call them line interactive, but ultimately transients on that line have a direct line to the load. And I think we talked about that last time. So double conversion UPSs, we're converting that energy 2 times, right? So it's coming in as AC, we're making it DC, then making our own sine wave back to AC. And so that decoupling is kind of what we're considering that to be just as important as the power backup in that, right? I want none of these transients to be available to the load. When we go in eco mode, we're riding on the static switch. We're essentially, and I like to simplify it and say we're turning a double conversion UPS into a line interactive UPS in a lot of ways, right? So we're saying we're going to ride on that bypass. We're going to give the input a direct line to the load, okay? And there's different forms of eco mode or e-conversion modes. There's different ones out there that some can inject VARs into the line to do some power factor correction, things like that. But ultimately, we're kind of saying we're opening up that path to the load. And so we still have some filtering there, but it's not quite the same. But because it allows us to traditionally turn off or at least pulse the inverter to keep the batteries charged, some UPSs actually have a bidirectional inverter that allow the inverter to actually charge the batteries, so we can leave the rectifier off completely. Those can be a little bit more efficient, but for the sake of efficiency, that conversation in eco mode was really a big push in, more towards the early 2000s, where we had just come out of not the double conversion, but the 2-layer inverter UPSs. And we were used to seeing UPS efficiency in the 80, 82, maybe 84%. And we just recently took a big jump all the way up to into the 90s, 92, 93%. We were very excited about that as an industry. And so eco mode was kind of the next big piece from Eaton that kind of went and was like, well, hey, why not just go into this mode and be really efficient? And, I think most engineers would agree that, we can use some of these things on the B side of a 2-end system, but they kind of overshoot the mark for the original intent of what we want the UPS for, which is the full package of the full protection, including the transient response. So it really depends on the application. We do have some customers, there's customers that I've worked with and done installations for that will use the eco mode for the B side, or they'll use, or they'll even use it as the primary. Sometimes there's several, still a few. It's very small. It's probably less than 1%, but that will use an eco mode on a single threaded system because efficiency is their number one thing.
Sure.
Frankly, the only end users I've really seen that is usually higher ed, colleges, universities. Those are what I see where they have some real serious green initiative that they're trying to target,
Sure.
And that allows them to meet that initiative. But that's really how I see it. Once you get into the commercial space and government space, it's like, I don't want to take any chances. I want to use the full value of what the UPS can do.
Right. I guess I've never actually seen it operate in eco mode. We'll test it in eco mode to see it's working right and everything, but we always leave it in normal double conversion. So is there a lag when it switches or if you're in eco and you lose power?
So there's the ITIC curve, right, which ultimately kind of tells us, hey, this is the window that we have to respond in to keep all loads running. There are different class levels for eco mode. And so the most stringent would be double conversion, and that's what we're all manufacturing UPSs to say we have to respond in this window. Where traditional eco mode and most eco modes have a different window. The problem is, as an engineer, when you're designing something, you don't get to dictate the type of equipment that the customer might plug into this space to say whether eco mode's going to be acceptable or not. And I don't know the particular curve for whatever load the customer might use. So for us, of course, the safest answer, being engineers, shocker, conservative by nature, we fall back on let's just stay in double conversion. But there are some customers that are like, well, we're fine stepping into that realm and going that way. Some of the different eco modes out there, and e-conversion mode, do meet the most strictest version of the ITIC curve. So they will meet the same class 1 level curve as a standard online double conversion UPS would. Not all of them do, but some can. So that opens up the window of a little bit more flexibility around that. I still think at the end of the day, even the best modes of efficiency, since most UPSs are in that 96.5 range, 96 to 97% efficient, when we go into some of these other modes, we're only gaining a point.
Right.
Maybe it's 1.5 points at the most, right? So it's like, that's a lot of, first off, you spend a ton of money for a piece of equipment that does all of these things that you're now going to basically say, I'm not going to use, right? But then on top of that, what is the real end gain out of the whole thing, right? I can't imagine, it's not that an outage is really the ultimate response to that. I don't think it's safe to just reasonable to go like, well, if you do that, then your cost is an outage. You're probably still not going to have an outage, but is it worth the risk anyway?
Right.
I think it's a risk. It's a question everybody's got to ask for themselves, and they can, and that's fine. But yeah, we don't see very many people willing to take that step.
Well, and like you even alluded to, it's more than just an efficiency that you're buying a UPS for, even the double conversion, because it cleans up your power and all that
Correct.
stuff too.
Yeah, I want my own completely created sine wave from this box, and that's what the load's going to see, right? The inverter is what's doing all the work. I want that load to have that benefit versus something else dictating it. Frankly, that's what most of the money I spent on the UPS was in the inverter as the piece of equipment that's going to supply my load. And if I'm not using it, only other than as an outage response, then yeah, it's a little, I don't know if it's silly, but it's a little bit,
Yeah.
We spent all the money. I think it's best off to use it.
Yeah. And let's use it to its full capability.
Yeah, correct. That's why, if you got a 2N system, sure, save a little money on the backside. But once again, does it scale well? Does it make sense to have, if you got a 2N system that's 100 kW, that's operating at, it's a 2N system, so everything's operating at 40% or 45% load. What am I saving? 1% of 45 kW, right? So 450 watts is my savings, right? Do I care about that much to potentially, reduce the capability of the equipment feeding my load? I don't know. I would probably not bother with it, but some people might.
Some people do.
Yeah.
And that you even mentioned in a 2N system, the load is usually probably like 40% to allow for carryover. If A side fails, B side can pick all that up.
Certainly. How
does running at a lower load than say it's designed for a nameplate, how does that affect harmonics?
So there can be I don't feel like low load is an issue. The biggest problem is no load, right? When you think about the amount there is some reflected harmonic content because we have this giant switch mode power supply piece of equipment, right? This UPS. So, and there are limitations on what can be put on the bus, but they're ultimately immediately overwhelmed and negated by almost any load on the UPS. But we have seen customers turn things on and look at them with no load And they're like, well, the harmonic content is very high as a percentage of load. And when you're looking at a standard that's dictated on a percentage of load, well, it looks crazy. Well, what is the load? Well, it's 0. So if it's 0, of course, right? So let's put some load on the piece of equipment. Let's see what we have and go from there. Downstream of the UPS, right, harmonics and power factor are determined by the load. The load tells us what those are. So that's another thing we've run into commissioning UPSs and stuff where people are like, hey, we're getting all of this content or this stuff is here. Well, the UPS is responding to what the load is asking for. It varies depending on what the load is, but yeah, we need to make sure we're looking at what the load is. And if it's a purely resistant load bank, obviously it's probably not the issue. Then we might need to look back at the UPS. But for the most part, got to look at what the load demand is first, and then go back from there. But yeah, the lighter load you look at, it's look at just even it's as simple as looking at even a UPS efficiency curve, right? You got this curve that starts at it's never at 0. It's going to start at 3-4%, and then it's going to go up and be flat, right? Well, down in this range, we don't have a lot of normal operating data because we assume that we're putting load on the UPS, right? And of course, losses and everything else in there, the inefficiency of the unit is all of it at that point, right? So we just got to be a little smart about not freaking out about reports if we're commissioning things or looking at test data unless we actually have some true load and are kind of looking at the equipment. So that's my thoughts on it.
Harmonics are not nearly what they used to be, right?
No, I mean, the first thing when I'm doing presentations or talking to engineers and groups, one of the things I ask them is when's the last time you ran a 5th wire, right? When's the last time you ran a double neutral to anything, right? Well, it's probably been 20 years, right? For those of us that remember running double neutrals to everything or number 10s to receptacles out throughout the building, right? Because we were so worried about the harmonic content. We remedied that by jumping on board. The NEMA standard wasn't quite there, but the IEC standard was, and kind of the combination of those getting us to where we needed to be to eliminate the harmonic content at the source, at the switch mode power supply by fixing that standard versus continuing to overbuild projects for the sake of trying to, put giant Band-Aids on it. Yeah, we don't see that as a major concern anymore. I mean, occasionally we still see we'll see some random spec that somebody hasn't updated or something else, and they want 200% neutrals, and we're like, you don't see a use for that anymore. I mean, there might be an argument where somebody knows about some piece of equipment or something that's more of a concern, but that's, to be honest, the last time I ran into a significant harmonics problem was in wastewater treatment, where we were backing up a bunch of UV lighting banks.
Really? Right.
So yeah, a bunch of banks of UV lighting for wastewater treatment for treating the water, and all the lighting ballasts for all the UV lighting they were manufactured overseas at a very low cost, and had there was almost no standard with them. So the harmonic content was a problem. It was significant. So that actually led them to just put UPSs. Backing up all the lighting. That was also beneficial because they stayed on, because if they don't stay on, then there's a certain amount of water they can't use, and there's a bunch of other standards, right? Like that water wasn't properly treated and everything else. So, those are megawatt sized units sometimes for some of these lighting packages for the UV stuff. So, but that's the last, to be honest, the last real big drive in the spec that was like, we're really concerned about harmonics and how do we address it. That was the last one I saw, and that was easily a decade ago.
Interesting. Yeah, I know it's been pointed out to me that double neutrals are a thing, but it doesn't exist. Not that it doesn't exist, we just don't. Mm-hmm. It's not as necessary.
Yeah, there was a time, and this would have been when I was in Silicon Valley, probably with Cupertino, where we would, every set of plans, everything said 5-wire, right? All the schedules, all wiring schedules, everything said 5-wire. That was just the norm. You expected it. And then, almost overnight, that disappeared. It still kind of lingered in the IT space, but for the most part, it wasn't necessary, but definitely don't see a need for it today. It doesn't make it, don't see a drive for it.
Yeah. Okay. What about power factors?
So power factor, another thing really determined by the load, right? The load will determine the power factor. Obviously, you plug in a bunch of motors, we'll see a significant lagging power factor. One of the things, back to the original part of the conversation, when we switched the standard for switch mode power supplies, they got a lot more filtering built into them, but that ultimately makes them a lot more capacitive during light loads. So one of the big changes we saw in the 2008, 9, 10-ish realm, we started to see data centers doing big IT refreshes with new equipment. Harmonic content went away with the new servers and their new power supplies at the new standard, but all of a sudden they were operating at a leading power factor. Because those power supplies were so much more capacitive on a per server level, and we were still in the mode where we weren't really virtualizing things in the data center. So we were at a bunch of 20 to 30% loaded servers. Well, at that load, the capacitance that would normally properly filter it at 100%, now those power supplies become very capacitive. And so we would walk up and regularly see leading power factor on UPSs. Well, back then they weren't designed to handle leading power factor, so they were met with some pretty serious derations. There were some facilities that had up to I remember one had a 40% deration on their UPS due to leading power factor. So those weren't crazy. I mean, those were just the reality of we didn't engineer UPSs around being able to support any leading power factor at all. Then some manufacturers started getting on board with that, and we started seeing a lot more designs around UPSs that handle leading. Now that's an industry standard. It's one of those things that wasn't a problem until we knew we had to engineer for it, and then once we knew, we did, and then it was fine, right? From a UPS manufacturing standpoint, it was just as simple as going, oh, we need to design this to be leading as well? Okay, cool, we can do that. Let's design it this way, and then it was fine, and it hasn't been a problem since. So you'll see most UPS manufacturers are usually at least 0.9 leading or more. And that's usually about as much as you'll ever see in a data center, is you'll get close to that 0.9 leading. But once again, that's just the load determining the power factor. And that's a clear indicator. We have a good sized data center with a lot of partially loaded servers that have a ton of stored capacitance and energy in those power supplies.
Right. Okay. So let's talk about some of the applications for UPS. I'm used to seeing them in telco. They support basic controls for switchgear, maybe some life safety type of stuff, but that's generally it. What else are you seeing UPS is used for?
Yeah, so it's interesting. The market's kind of really, I don't want to say emerged, but it's changed quite a bit. I mean, in the last, maybe 5 years, maybe it's been 10, probably definitely the last 5. The sheer number of things that customers say now can't go down and must be backed up, it just keeps growing, right? So for a normal build, we used to talk about, UPS systems. Is it a data center? Okay. Is it a hospital? Okay. Right. But those are the two main segments. There's a few other places, right? Medical imaging, a few other things, there's some ties, but now it's, this can't go down. I have a 5-axis mill that can't go down. I have this other piece. There's so many different industrial pieces. This conveyor system can't go down. Hey, these PLCs can't come down. Hey, this control center for this oil refinery, whatever, or even just pumping stations. Like, there's just so much. And I think it's really because there's so many things that are just oriented around so much controls and the constant monitoring of those. So, it's kind of cool, but we definitely see more and more UPS is backing up more and more things, and you'd be surprised at just the random stuff that we see. I mean, refrigerators for research is a place, so we see that. Generators can usually handle those pretty well, but some places are like, we want UPS. So it's just that blurred line, between generator and there. And then the flip side of that too is with runtimes being able to grow significantly by utilizing lithium, and the fact that those footprints are very small now with lithium, where with valve regulated, we just might be so big that we couldn't find a place for it. We're now seeing, well, I would normally put in a generator and then a UPS and a battery, but it's like, well, wait a minute, I can probably get enough battery to really handle what I think I need and not have to deal with the issues around having a generator at all. Right. So we're seeing more and more of those types of applications. I mean, the generator to me, the biggest reason you need that for a traditional IT space is, hey, the UPS is going to keep the servers running. And we have these conversations with customers all the time. They're like, well, I want just give me an hour of runtime on my UPS or something, and then I won't worry about the rest. And I go, well, what's going to keep your data centers cooled for that hour, right? You need the generator to run the mechanical equipment. You really should have it to refill the UPS, but UPSs are designed for short-term outages. They really aren't. We're not really designing them to run for 2 or 3 hours historically. But we see more and more of those applications as the loads become more specialized, like feeding a conveyor belt or a mill or something. Well, there's no HVAC component to those running. I just need those to run, or I just need the controls to be supported. So we're seeing a lot more UPSs in lieu of a UPS generator combo and just extended runtime, even at smaller sizes. And for something somebody just wants to see up for an hour or long enough that they can coordinate a shutdown. We're still having the conversations with people that I'd rather not have, where they're like, well, I want somebody to wake up that lives a half hour away to get up and get a signal and drive in and do all this stuff. And then shutdowns, you're like, okay, so like we're at 3 hours of run. Sometimes these requests are a little silly. I always say that, I get paid to sell batteries, but I'd like you to buy as few of them as possible if we can help it. Because they are consumable. I mean, I'd rather just not have the batteries out there if we can. But there's more and more applications that we're seeing the driver for those types of applications across the board that are outside of your traditional spaces.
What's the longest runtime you've seen specified?
Oh my God. Well, we have a whole nother realm where we work in microgrid and BESS. So battery energy storage systems can get exorbitant.
Yeah.
But as far as UPSs go, of size, I mean, we see plenty of rack mount stuff where people are like, I want this rack mount UPS to run for 8 hours, which is silly. Normally you're running out of, and this is important for people to know, we're normally running out of DC charging capability. That's typically our limitation. Like you want 8 hours of runtime, but the rectifier in the UPS can only maintain a float charge and recharge up to 6 hours. And so there's where we start running into some, if you think about it, I mean, there's a massive amount of storage and we're charging it from this one little box.
Right.
So sometimes we have to upsize the UPS just to get a larger charging circuit in the box. So somebody goes, well, I only need 50 kW of UPS. Well, you're going to get 100 kW UPS because we need the additional charging capability, not for the load or the throughput, but for charging. So there's some of that. But yeah, in big sizes, we've done a few at 6 to 8 hours in that range. We're almost always trying to talk them back down off of something like, it's a massive amount of time. It's not a DC plant with inverters, right? It's a UPS. So, those are usually where we're at, Quite a few 4-hour runtimes still, once again. I mean, when you get to any size, 200 kW, I mean, 4 hours of runtime is a massive amount of energy storage, right? So it's then the conversation is okay, I know that you want the UPS to be a 200 kW UPS, but what's the real load, right? Not just what you think you need to size it at, but what's your actual load? Let's size the batteries for the load, not just for the frame of the UPS. And that's something I recommend as a whole anyway for any engineer. We're always going to oversize things. We're always trying to cover that. We don't know if the customer's ever going to grow to that point. It's very easy to write a specification that says, I want a 200 kW UPS, but in the specification, write that battery runtime is 5 minutes at 100 kW of load, or 80 kW, or 125, right? You don't have to always say runtime at 100% load, right? I know that might be the easiest thing, but we're making customers put in a lot of batteries for our projections that they may never use, right? We already know they're not likely to use them anyway. So there's to me there's an argument for that.
Yep. Well, and then I know lithium has helped a lot on footprint, but if you're looking at VRLA, I mean, you start getting into those 4+ hour runtimes. That's just a ton of space even for batteries.
Yeah, it's massive, and the weight becomes incredible, right? You have 100,000 pounds of batteries in a space, right? So, you got to look at all options and stuff. I mean, lithium comes with its own challenges and stuff, and more new challenges here recently, right? So, there's a lot to look at, but it's there's ways around it, and there's things to think about before you start just sizing it one way or another.
Right. Have you seen just complete replacements, I guess, of life safety generators with a life safety UPS?
Yeah, so it's a good question. A lot of manufacturers have UL 924 boxes. We're kind of initially, obviously, we're going after the lighting, but that's been going around for 20 years. If you get the right size application, we've had a few. But now what we've done here is, storm shelters have kind of opened the door, but where we've done it in several buildings is where instead of a generator, right, that traditional generator transfer switch pair, X amount of runtime, we're just doing the life safety, lighting, egress, elevators, everything with a lithium-ion backed UPS.
Yeah.
Right? And so when you think about in downtown or some other parts, or frankly anywhere, the coordination effort around where to put the generator, how it'll be connected, how do the exhaust requirements are, what are the runtime hours, what's the air quality management concerns, sound attenuated enclosure, all this kind of stuff. We can hit all those pretty easily with the UPS. It's more expensive, but it's not as much more expensive as you think. In fact, at the end of the day, once you've coordinated the full site and the install requirements, it might be less expensive, right? Depending on what it is. I also think it performs better. The least maintained piece of equipment in an electrical one line is the automatic transfer switch, because it's live all the time. We rarely go in, we don't touch it, we don't do work on it. Nobody shuts down their buildings to do it. Whereas instead of having to wait for the transfer switch to do its job, the UPS is always online and always in the circuit. It's already running. Like, I know the emergency lighting circuit works because it's being fed by UPS and the lights are on. Right? Because the UPS is already in that power path. Where the transfer switch, I'm going to have to wait and see if it transfers or not, right? And that's usually when we find out that they don't work, is then. It's usually not the generator. Lots of transfer switch concerns there. Once again, because they're not maintained. It's not necessarily the switch's fault, right? But there's a system we don't do. Add in the fact that, local jurisdictions are trying to get us away from burning hydrocarbons at all. Right? They want to take the gas stoves out of our homes, right? Those kind of things. Well, then let's get the generator out of there too, right? So we see a big push for that. Recently, for a lot of the work we've done in Iowa, in the state of Iowa, their standard for storm shelters is now lithium, no generators, none of that stuff. It's just lithium-ion backed UPS for all the fan controls, the fans themselves, everything. So traditionally we would say, let's keep mechanical systems off of the UPS.
Right.
We don't see that limitation anymore. We put mechanical systems directly on UPSs. Across the line starters are still fine, but we got to be able to handle that inrush. But most of the time we're going to put a VFD or some kind of soft start or something on the fan anyway. So that eliminates any of that concern. So we see more and more mechanical equipment being put on UPS systems as well in that regard. So a whole new application, a whole kind of new window opening up.
Yeah.
For that.
Okay. I know lithium has kind of taken the forefront with batteries. I think you've mentioned zinc 5 batteries.
Yeah. Zinc 5 is the battery technology out there as well.
Mm-hmm.
We've seen some applications with that. It's still a very small player in the grand scheme of things. Definitely a distant. A distant third or fourth behind your traditional valve regulated or wet cells, and then lithium. I don't even know. It might catch flywheels. Flywheels have always been kind of a small piece. I think we talked about that before. But yeah, it's a new emerging type of technology that people are looking into for sure. So most UPSs should be compatible with it. So no real reason to not look at going down that road. Performance seems to exceed your traditional valve regulated batteries. Of course, the valve regulated battery manufacturers have all kind of upped their game here recently too in response to lithium. We'll kind of see. It's one of those things that we have a lot of long-term history with things like lead acid and lithium. We've been using them in many devices, the zinc 5 stuff and just the zinc batteries. And there's several forms of zinc out there. Zinc 5 is kind of that's the brand name, right, of that particular battery. But there seems to be some good information. We just don't have a lot of long-term history on that particular battery's function in this world and stuff like that. So I think a lot of eyes are just looking to see how it goes.
Okay. What's the biggest benefit you see with zinc 5?
Um, Honestly, I think probably the coolest thing is it's got a much more ready form factor. So when we go into a traditional valve regulated space, we can swap out an existing lead acid valve regulated battery in several instances, not every, but some, with a like for like looking battery. It looks just like a lead acid battery, but it's a zinc battery.
Oh, really?
Right. So
Okay.
yeah, you can go right into the same cabinet.
Okay.
To me, that's probably the biggest benefit
Yeah.
right now for it. But yeah, jury's out. We're still kind of waiting to see how long-term performance goes and stuff with some of those things. So we're, I wouldn't say we're skeptical of that as much as we're skeptical of everything
Sure. Right.
until we see it perform. So we'll kind of keep watching it. But yeah, it's got some neat stuff. That's one of them for sure.
Okay. Good deal. Any other new or exciting things happening with UPSs that you're aware of?
What else is going on? The one thing I think we had discussed we might kind of look into a little bit or chat about was just some of the standards changing and things around UPS as a whole. One thing that I wanted to kind of touch on around just engineering in general, it's kind of become a more recent soapbox. So you have UL standards that basically manage, what we have to build to, right? What our standards are for testing. When it comes to external bypasses and switching, okay? So there's 1778. That is basically UPSs, UPS accessories, things like that. So if an engineer or a customer says, I want an external maintenance bypass for my UPS, most of the time we specify external maintenance bypasses. External maintenance bypasses have one output on them, okay? That one output allows them to stay in the 1778, the UPS accessory specification, some overlap with 1773, but allows it to stay in that listing, okay? When we start adding distribution to the output of that, we are no longer in that listing anymore.
Really?
Yes, so I like to caution the engineers. We get excited about the idea. It's like, well, if I just have one more breaker on that output, I could kind of make my one line a lot easier by adding that piece, right? So we're going to completely deviate from the normal typical standards. So we're already off from what we're building, a manufacturer of UPSs is building thousands of, which is a standardized bypass that fits under UL 1778. And now we've modified it to be something else. So it's now a custom piece of equipment. So even though it can be done, it's more of it should it be done. So a recent example of that had a project with a 625 kVA UPS, 1000 amp output. Okay, and the bypass would be a normal 1000 amp output for it. The customer said, well, I want not just that 1000 amp output, I want an additional 225 amp output. This is the engineer. And so I can feed that panel board and then feed this equipment. Well, a standard normal off-the-shelf bypass for that UPS is about $24,000, okay? By adding just one additional 225 amp breaker, that bypass now costs $117,000, okay? All we did was add an additional 225 amp feed. But it took us out of our normal listing. It puts us in a totally different set of UL listings with a different type of manufacturing standard, everything else that has to be done, right? So there's a lot of things where it's easy for us to draw them on a piece of paper and go, hey, I'll just take this shortcut. But the cost ramifications of things on the rest of the side are huge. Whereas, let's be honest, I could have bought the standard bypass for $24,000, and then what's a 1000 amp panel board cost?
Right.
$7,000-8,000, whatever. It's not a lot,
No.
right? So we still could have saved nearly $100,000 by just not adding that breaker. So we just, I think, as engineers, be a little bit more cognizant. And then just because a UPS representative can come to you and you ask them a question, hey, can you do this? Well, just because you can do it, right? I'd like a little bit better technical representation out of the people out on the street to go we can, but let me explain to you, Mr. Engineer, what the actual ramifications are of you doing the thing. Right. So that's probably my biggest, soapbox on those things. There's some changing standards where UL has recently now decided that 9540 is now going to be over all forms of energy storage and energy conversion around UPSs, where traditionally we saw that only as a BESS standard.
Okay.
Now it's kind of a lot of people would say infringing on your traditional UPS standards. So it's causing a lot of pain for a lot of manufacturers and new testing requirements and everything else. So there's some stuff around that that's really kind of causing some issues, because you now have to get your stuff listed not only as an energy conversion device, but per type of energy storage.
Sure.
9540A, which originally invented or created just for lithium, we're now, with the building code changes, we're now seeing that we're going to have to tighten up on that code. So there's some new testing and stuff I'm sure coming out from UL on that, which is good. Let's keep making things safer and keep perfecting this stuff around lithium. Lithium is not going away. We're not going to decide that lithium is just not the right answer. No, we're going to keep pounding on it until it's as safe as it can possibly be, right? We already manufacture it for buildings. We already manufacture it in a totally different standard for buildings than we do for vehicles. So we shouldn't conflate the two. We shouldn't worry about a car catching on fire and then go, well, the building's going to catch on fire the same way. It's not. It's different. We do things differently inside this space for UPS lithium. But more and more testing, more and more safety standards, things like that. And some of that is now coming back onto lead acid and other things too, because recently, it's kind of funny, as much as, I've worked on projects with hundreds and hundreds. I'll probably have done thousands of lithium-ion cabinets myself for UPSs. I've never had one have an incident or any issue with fire or anything. I've had many incidences of valve-regulated lead-acid batteries. Yes, so I think there's been enough pushback rotating around where now they're like, hey, we developed this testing standard to preclude for fire because we're worried about that. We should probably be testing all forms of energy storage, not just lithium. So now I think there's pressure coming back on the lead acid side as well around that. So it's going to be interesting to see. Everybody's kind of scrambling a little bit right now, trying to figure out how to meet the new standards and what authorities are actually adopting them. Because most of the country, from what I've seen, nobody's adopted any of the new standards. Everybody's just trying to get ahead of them.
Okay.
And so we'll see. And many won't adopt them, or some of them won't adopt them for years, or chances are those standards will change again before they get to the point where somebody adopts them. So they'll probably miss the window of when anyone cared.
Yeah.
So it's interesting. We're in this weird kind of interesting transitioning period here for probably the next year or two, kind of see what it's like in the industry. Because it's all about the kind of conflation of standard BESS and your traditional UPS, how we used to keep them completely separate and say they were different. And now UL basically like, nope, they're all the same. We're going to put them on this one big envelope.
Okay. Awesome. Well, thanks for all that information. Those standard changes are going to be fun to deal with.
Yeah, it's going to be interesting to see how things shake out for sure. There's no doubt. We're going to be along for the ride for most of it.
Yeah.
So, we'll kind of see what happens.
Yeah. All right. Well, thank you for joining us on this episode of TechXperts. Robert, thank you for coming in today and taking some time out of your day. We will talk to you on the next episode of TechXperts.
Thanks for having me.
Thanks, Robert.
Thank you.